Hi, I'm Ayana Stevenson, and my extension project is on the biological effects of loneliness. Loneliness is defined as perceived social isolation, meaning someone feels socially disconnected even if they're around other people. This presentation examines how loneliness biologically impacts the brain and body, and how these changes affect emotional regulation and social behavior. My specific question is, how does loneliness alter brain activity and biological processes, therefore influencing how people respond to social situations? To answer this, I will focus on three levels of analysis: neuroanatomical, network or systems, and neurochemical. One research method used to study loneliness is functional magnetic resonance imaging, or fMRI, which measures brain activity by tracking changes in blood flow. In one study, participants completed trust-based social tasks while their brain activity was measured. As shown in the image, lonely individuals showed reduced activity in reward-related areas like the ventral striatum and changes in the amygdala, which is involved in emotional processing. This suggests that lonely individuals may find social interactions less rewarding and may expect more negative outcomes in social situations. At the neuroanatomical level, loneliness is associated with differences in specific brain structures. One study found that higher loneliness was linked to reduced gray matter in the posterior superior temporal sulcus, or PSTS, which plays a significant role in understanding social cues and interpreting other people's intentions. As shown in the image, this area of the brain is smaller in individuals who report higher loneliness. The amygdala is also involved in emotional processing, especially in social situations. Because of these structural differences, lonely individuals may be more likely to misinterpret social cues and respond more negatively to others. At the network or systems level, loneliness affects how different brain regions communicate with each other. Research shows reduced connectivity between regions like the amygdala, insula, and prefrontal cortex in individuals experiencing loneliness. As shown in this figure, there is less communication between these regions, especially involving the anterior insula. These areas normally work together to support social decision making and regulate emotions. When this communication is disrupted, it can lead to lower trust and more negative responses in social interactions. At the, neur- at the network At the neurochemical level, loneliness affects chemical signaling in the brain. Research suggests that loneliness is associated with lower dopamine levels, which reduces the reward from social interactions, and lower oxytocin levels, which reduces social bonding. Loneliness is also linked to higher cortisol levels, which release increased stress, especially in social situations. These biological changes can help explain why social interactions may feel less rewarding and more stressful, which can lead to social withdrawal. Overall, loneliness affects the brain at multiple levels, including brain structure, communication between regions, and chemical signaling. These biological changes can help explain why loneliness can affect emotional regulation and make social interactions more difficult. This shows that loneliness is not just a feeling, but something that can change how the brain works and influence social behavior. These are my references. Thank you.